scary, no? In choosing a school, a course, or a career path, there is so much to explore. But that's why we're here. Don't know where to start? Mag-browse ka muna sa blog namin. Baka ma-inspire ka sa mga student advice, study hacks, and adulting guides. Meron kami niyan dito. Or learn about career paths that match your skills and interests. Or chat with us. Tanong mo lang, we'll point you in the right direction. O let's say may dream school ka na. You can search for it and learn more about their programs and scholarships. At kung di ka pa decided, don't worry. Search and compare different schools to fit your needs. Pag ready ka na, submit an application. Easy. Maybe you're looking for a new hobby, certification, or degree? We've got online courses for that, and the learning doesn't stop there. Join a quest and pick something up with each visit through articles or videos. And the best part, you get to earn coins and redeem real rewards. Kaya sali na! With the right tools and information, we can find the best opportunities for you. Because the future can be scary. Pero tiwala lang. Keep exploring, keep learning with Edukasyon.ph.
AWS Fault Injection Simulator is a fully managed chaos engineering service that makes it easy to discover vulnerable paths in your applications. AWS FIS helps developers easily set up and run controlled chaos engineering experiments across a range of AWS services. FIS gives you the ability to inject faults, such as latency or failure of underlying compute networking databases and more. That includes control plane level faults, such as API throttling and server errors, that weren't previously possible for customers to do this in the cloud. And FIS makes it easy to run safe experiments. We built it to follow the typical chaos experimental workflow, where you understand your steady state, set a hypothesis, inject faults, and monitor your application. When the experiment is over, FIS will tell you if your hypothesis was confirmed, and you can use the data collected by CloudWatch to decide where need to make improvements. FIS removes the barriers to adopting chaos engineering. I see a lot of benefits for incorporating chaos engineering into your business. From running game days or incorporating chaos experiments into your CI/CD workflows, most people think about chaos engineering for resilience. And that's true, but it's also performance improvements you can make. It is the blind spots that you can catch in your monitoring. And perhaps the most underrated is the experience your teams will get learning how to respond to infrequent but critical events. Mean time to resolution is not just about your architecture and automation, but it is also about the operational muscles that you build and exercise over time. There is no better way to test your system than chaos engineering. And with FIS, you won't need to be an expert to incorporate it into your organization. AWS Fault Injection Simulator will be available in early 2021 and will include the ability to run fault actions against services such as EC2, RDS, ECS, EKS, and more. Out of all the things we're announcing this year, this is the one that I'm most excited about. By offering this as a service, I believe that we can have a massive positive impact on building more robust, more durable, and more dependable systems in the cloud.
Welcome to the 26th episode of the Community Ignite series titled Automated Machine Learning Workflows with SageMaker Pipelines.
I am Joshua Arvin Lat. I am the Chief Technology Officer of Nuworks Interactive Labs. And I'm also an AWS machine learning hero. People think of AWS sometimes as a black box. However, AWS is an umbrella of different services. So that's how easy it is to introduce a processing step in your pipeline. So prepare the script, prepare the configuration, and link it to your workflow. We're doing this because we do not want to create a new inference endpoint every time the pipeline runs. We want to recycle the existing inference endpoint, especially if it exists already. One, that would help us save on cost, and two, you do not want to have 100 pipelines and you're only using one of them.
This event is for free and it also comes with an e-certificate, and this is co-presented by Amazon Web Services and AWS Sigla Pilipinas.
Welcome to AWS Educate's Cloud Career Pathway. AWS Educate helps you create a pathway into innovative and lucrative opportunities in the rapidly expanding cloud industry. On AWS Educate, you will discover the skills necessary to advance into cloud careers, explore content, test your knowledge, seek micro-credentials as badges and certificates of completion, and even have the opportunity to apply for jobs and internships in the cloud. Start off by building your profile, adding your resume, classes, degrees attained, and other facets of your experience. Then, select a cloud career field. From there, we'll personalize your plan by providing content that matches your pathway. As you consume that content, we'll prompt you to take knowledge checks of 3 to 5 questions in order to gauge your comprehension. After you've completed 50% of the knowledge checks, you'll have a chance to earn an AWS Educate badge. Then, up-level your profile by completing a project and a final assessment, and you can receive an AWS Educate Certificate of Completion. Take applicable courses at your school or online to grow your knowledge and fill gaps in your skill set. All of these achievements can be added into your portfolio. Then put it all together. Apply for a job or internship at Amazon or at one of our customers or partners through the AWS Educate Job Board. Download your portfolio and send it to your potential employer to get your ideal job in the cloud. So what are you waiting for? Start your career pathway today.
Operating highly available, fault-tolerant, and resilient applications is critical, but applying traditional disaster recovery tools to a dynamic cloud environment is challenging. AWS Resilience Hub is purpose-built for the cloud, so you can define, validate, and track the resilience posture of your applications. Defining RTO and RPO targets allows Resilience Hub to assess resilience weaknesses prior to deployment, while providing remediation recommendations to improve application resilience. Resilience Hub integrates with AWS Fault Injection Simulator to simulate real-world failures, enabling you to test and validate your application's ability to meet resilience targets. Keeping an audit trail of testing, failure, and recovery events helps meet regulatory and compliance requirements. Resilience Hub integrates with relevant AWS services to help you monitor applications for potential resilience issues. Get started with AWS Resilience Hub today.
The power of the AWS cloud is within your grasp.
That's why we have chosen the AWS Essentials trainings to bring everyone on the same level of knowledge. So when we're talking about cloud, everyone has a basic understanding what is meant.
Whether you are just starting out or looking for ways to scale and speed up your success, you have a need for cloud skills. AWS Training and Certification has solutions for AWS customers and AWS partners, as well as the next generation of builders and leaders. Developed by the experts at AWS, our training resources help you advance in your career, building cloud skills on your team to innovate and achieve business goals.
We made sure to provide all types of training because, as you know, not all adult learners learn the same way. Some learners prefer instructor-led training, while others prefer self-paced.
No matter your role, we can help you gain in-demand cloud skills, both introductory and advanced, and validate your expertise with an AWS certification.
Preparing for the exam really reminded me the fun and enjoyment there is when it comes to education and self-learning.
Whether you're developing a new application or growing a business, AWS Training and Certification helps the builders of today and tomorrow leverage the power of the AWS cloud.
All right, good evening and a happy Thursday, everyone. Welcome to the 28th episode of the Community Ignite series, AWS Fault Injector Simulator Demo. I am your host for tonight, Dar David, a Technical Community Manager of Edukasyon.ph, and I'm so happy to be with you guys today. So thank you for taking the time to attend this free 1-hour tech-driven webinar. And before we continue, I want to know how you're doing naman, di ba? Kasi syempre, kahit matagal na tayo nagkasama every Thursday, I know there's still something new to learn from you guys. So if you're a student, let me know what university you're from. Pag professional naman, type your career in the chat box. I would also like to greet din our FB Live viewers. So comment nyo rin, no? Pakilala din kayo. And don't forget to share rin sa inyong timeline yung FB Lives. So hello Ferdinand, hello Michael, hello Edison. Ang dami from Universidad de Manila. Hello everyone. Ayan, hello from yung mga estudyante ng Universidad de Manila. Hello po. So today, we're going to learn how to improve resiliency and application performance with controlled experiments by using AWS Fault Injection Simulator. So ano ba yun? What am I saying, diba? So AWS Fault Injection Simulator is designed to run disruptive real-world scenarios on AWS so that they are very difficult for teams to accomplish on their own. So yun yung AWS Fault Injection Simulator. So if you're new here, Community Ignite series are short. Yes, we're already starting, Loreto. Hello from AMA, from University of Eastern Pangasinan, from TUP, Taguig. Hello po. Ayan. So again, no, if you're new here, Community Ignite series are short episodes every Thursday, 6 to 7 p.m. It's where we bring people, product, and purpose together. So you, as a young IT professional, or early in your career, or just young at heart, or starting at the tech industry, you will definitely benefit from this series, especially that the whole series is co-presented by Amazon Web Services and AWS Ciclab Filipinas. So this event is all for free and also comes with an e-certificate. We will provide an e-certificate if you are able to answer our CSAT form to be flashed on the screen later. Facebook page po is aws.ciclub.ph. Yes, the webinar is recorded. So in the previous episode, the topic was all about building modern apps with containers. So you can check all about it on our social media accounts. So make sure to follow our Facebook, Instagram, TikTok, and LinkedIn to stay updated. Search lang AWS Ciclab Filipinas, or you can scan the QR code flashed on the screen. Hello, kay Ralph Pasel. Hello. Ayan. Hello again to our 83 participants here in Zoom and also to our FB Live viewers. It will be posted on our Facebook page. So, buong event na to ay 6 7 p.m. Mapopost to lagi sa ating Facebook page. Ayan. Sino pa? Hello, everyone. Ayan. From Bataan Peninsula State University. We have from Gordon College. Hello. Ayan. Thank you, Jaron, for coming. Ayan. And all right, mukhang ready na lahat for tonight. Can I get ready in the chat box? Can you guys chat ready if ready na kayo for tonight? Naku, mukhang hindi pa sila. Yon, daming ready. Thank you, everyone. All right. So our speaker for tonight has been in the information communications technology and operation technology domains for more than 25 years in various leadership roles with various enterprises on systems engineering, data center and network operations, information security, and solutions architecture. So he engaged with CXOs operations, corporate strategy, and IT of customers and partners with portfolios of end-to-end digital and enterprise solutions and technologies covering mid to large-scale business applications, operations, and infrastructure across various areas. So talagang bongga, no, ang speaker natin for tonight. So everyone, please give a warm welcome back to Sir Paul Sears. Hello, Sir Paul. How was your Valentine's Day? How are you tonight?
I'm doing great. Thank you. It was very nice. It's actually nice to kind of be able to go out and do things again with less restrictions. So enjoying that Philippines is returning back to a normal that I used to know when I first came here. So, okay. I really appreciate the introduction. Thank you. I love doing these series and it's You guys are amazing hosts, so I really appreciate the energy and everything. And I thank you again. So I guess I'll go ahead and get started, I guess. Okay. I'll share my screen so you can see what's going to happen here. I do want to mention a few things. So this is a continuation of a presentation I did a few months ago for the community series as well, Community Ignite series. And I was talking about using chaos engineering. And this is going to be part 2. I'm actually working on a session for our Singapore summit in May. And so I'm right now in a process of working on my content and working on a workshop and such. But I will be focusing on AWS Fault Injection Simulator. And so today we're going to give a little demo for you so you can see what it's like and how maybe you can use it in your environments and such. So as I mentioned before, this is the second part of my series so far. Okay, so let's go ahead and move on. So just a reminder, things are very, very complex. You know, your systems are getting more complex. So why do we even have this whole concept of chaos engineering? So a long time ago, when applications were monolithic, right? You had a single server that did everything and maybe a single server in a database, but it was very simple overall to understand how the system behaves, what's normal for that system, right? But systems in the real world and our modern systems in the cloud have the ability to be very complex and very complicated. As we shift to microservices architectures, you have a whole lot of moving parts and different pieces to connect together. So it can be very, very difficult to understand how the entire system is supposed to behave optimally, right? So so this is part of chaos theory, and this is where chaos engineering derives from. So chaos engineering is a discipline of experimenting on a software system in production in order to build confidence, the system's capability to withstand turbulent, unexpected conditions. So what you're really trying to do is understand how the system's behavior changes when something unexpected happens, right? So that's the whole foundations of this. And this is really, and as you saw the video earlier with Werner speaking about Fault Injection Simulator, it's really, you know, we want to be able to understand how to work on resiliency, but it's more than just resiliency, because resiliency is very important for your applications. You want your customers, your users to never have disruptions in what they're doing. So resilient systems are very important, but it also can help your performance. It also can help your security as well and everything else, because all these pieces all fit together in a very complex system. So understanding how a system behaves when there's unexpected change is very important. Okay, so these are from my last presentation. I'm just kind of recapping a little bit on here before I move on to the demo. So basically, as Werner also mentioned, that it's really a series of experiments, and you have to know the steady state. So you got to know what is the base behavior of a normal system. How is it normally behaving, right? And then you're going to hypothesize that this steady state will continue in both a control group and an experimental group. And then you're going to start introducing experiments, variables, changes that will potentially disrupt the system. And you want to try to understand if your hypothesis is correct or not by seeing the impact of what happened. That's fundamentally what we're doing with this. Now, in my previous presentation, I mentioned there's a number of tooling available. I started out with Chaos Monkey a long time ago with Netflix, and there's some other ones out there now. But now AWS released Fault Injection Simulator. I mentioned last presentation was kind of being released through 2021. It's now in full swing, and I want to give you a demo of what it looks like. But let's go ahead and get in this real quick here. So with our advanced principles for chaos engineering, you build a hypothesis, you vary real world events, you run your experiments in production, you automate the experiments to run continuously, and you minimize your blast radius. So it's very easy to look at your system and do something. I remember a long time ago when I used to manage data centers and deploy production environments, we would run around into our big data centers and turn off servers every so often, just randomly, to see if we were able to understand what happened. It was kind of a very brute force way of doing it. And it's also very difficult to do a large scale and automated experiment when you have to have someone go in there and actually turn a server off or unplug a network cable or do something like that. So the automation is very important because you want to be able to integrate these processes into your development lifecycle, your CI/CD process, to catch these changes in behaviors before you actually deploy into updates into production, to make sure you can mitigate those before they're actually deployed, right? So you really want to take advantage of automation and run things as much as you can. Okay, so let's talk about Amazon Web Services Fault Injection Simulator. Okay, so this is a managed service. I'll get into some details on here, but basically what you have here is you use a set of experiment templates you're going to create, and then you run experiments, and currently against a couple services we support. We support EC2, excuse me, Amazon RDS. We also support EKS and ECS. And then you can get output. You can also monitor conditions through CloudWatch or EventBridge and such. So you'll use these templates to start an experiment. And then when certain thresholds or certain stop conditions happen, the experiment is stopped, and then you view the results. Okay, that's the fundamental premise of this. So AWS has taken the steps of chaos engineering and kind of made it in a way that's a managed service where you can do these experiments very easily. Because previously, as I mentioned before, you had to find ways to do it yourself, maybe a manual thing, or maybe you wrote a script, a PowerShell script or a Bash script or something else to run these things, or you leverage some existing tooling like Chaos Monkey or Chaos Gorilla or some of the other tools that work maybe on containers, right? So there are a number of tools out there, but this is a service. You don't need to do anything. You just can build the experiments, and you'll see how to do this shortly, and you can run the experiments against your infrastructure. Okay, so it's a managed service, as I mentioned before. It allows for safe experiments and rollback. So it actually can roll back the state of your system prior to the experiment starting. And minimize your blast radius, so you can be very selective on the targets and the scope and such, right? And it also supports, as I mentioned before, EC2, ECS, EKS, and RDS. I don't have any information on future services, but I'm fairly certain that as the service is continued to be developed, they'll be adding more services down the road that will for sources and targets. Okay, and here's how you look at it. Here, some experiment templates. They actually comprise of three pieces. You have targets, which are going to be where you're going to perform your experiment on. You have actions, which are what are you going to do as your experiment, and you're going to have stop conditions, which may either be like you just let it run until it finishes, or maybe you have an alert or alarm that you'll monitor for, and if that alarm condition is triggered, you will stop the experiment. Okay, so these are basically how a template looks like, the three components to a template, and it has targets, actions, and stop conditions. Okay. So we're going to basically we're going to play around with Fault Injection Simulator using a best practice website workload. So this best practice meaning that it's resilient. We don't really have any single points of failure. So what we have here is this architecture showing here. I deployed it already to an account, and this is now running, and there'll be a website I can continuously update and check to see how the behavior is, as well as looking at logs and some CloudWatch metrics as well. So the first thing is we're going, for resiliency purposes, we deployed our web server instances across multiple availability zones in a auto scaling group. And that will handle any situations where an instance fails or an instance needs to scale out based on load. We also are using RDS, but with a secondary as well for a failover condition in case RDS primary fails, you can fail over to the secondary event. And then we also are using things like S3 buckets for some static assets, and Amazon EFS is also something you can use particularly for websites that may have shared code, because it's a shared file system that's extremely durable and resilient. So this is kind of the architecture we're going to play around with, and we're going to get into how you can experiment on things like this. Now, most architectures, honestly, when they first start out, are just a single piece of this, maybe a web server and a database, and that's it. So those have the experiments have a more dramatic impact on the availability of those websites when you run against that. But in a best practice, we should be able to tolerate a lot of disruption in our infrastructure before we see any impact. And we're going to play around with that and see how that plays out. Okay. So let's go ahead and get into FIS, and let me switch to my web browser. Hopefully you can see my screens here. I need to move my Zoom bar because it's in the way. Can I do that? Maybe I can't do that. Okay. So I have a number of tabs opened. I have a infrastructure already running. In fact, you can see right here as 3 web servers. Let me refresh this here. Let me close this. Okay, hold on here. The dangers of sharing an entire screen because application pop-ups. Okay, so I have 3 web servers running, and they're running a very basic application that generates a website that looks like this. And this is based on a workshop that we can send out links to later. I don't actually have it right now handy, but we're in the process of revamping some of these things. But this you can see here is using a load balancer, and you'll notice here that the instance ID changes every time because it's hitting the different servers based on availability of the server and the load, right? We're hitting, I'm playing out of Ohio right now, US, Ohio. We're using some very small instances and such right here. This is basically the very simple website that we're running, but it runs in a resilient manner. So if I go back to my infrastructure, you'll see 3 web servers. I have database in the back end. I have a load balancer that's an ALB in this particular instance, and the load balancer has target groups which have instances involved, and it has conditions around it. Here's my target group right here, and so and so. I won't get too much into this here, but you'll see 3 is the desired state. I'm actually running across 3 availability zones. So I have 1 web server in each AZ, and I'm going to basically you rely on the load balancer and auto scaling to manage my instances in case of a failure and such. And we're just doing a very basic health check. We're just checking port 80 for a 200 success. That's all we're doing. Nothing complicated in this. This is a very, very simple configuration. And you can actually get very complex. You can use on all different conditions and alerts and stuff to manage this. Okay. So I also set up a little CloudWatch dashboard. It's very basic, doesn't do a whole lot. It just captures some things that I might be interested in, like number of requests, if my static checks failed, if I have any 500 errors, which would indicate a failure and such. This is very basic, nothing here special. I don't have any alarms set up. I didn't feel like doing that right now. Again, this is just a very simple demo to give you an idea how the fault injection simulator works and how the console works. Okay, so let's go back to here again to EC2, and you'll see the 3 instances that are running. Okay. So let's go ahead and get into the fault injection simulator. So if you go to the console, you can type in FIS, or you can search for fault injection. I'm already on the console, so let me go to another service first. So won't do that. Let's do this EC2, and then I type in FIS. Whoops, I'm a little lag here. FIS. Here we go. You can search for it there, and you can go to AWS FIS. So when you do that, you'll get an initial loading area. We always have our sidebars that pop out on the left, and it's a very simple console right now. It kind of describes how it works, some benefits. There's some documentation, what is chaos engineering, how to use templates, getting started, etc. You can look into and so on, some facts in case you want to learn more about this. We're just going to do a very high level demo of this so you can see what it's like. But this is again a basis of a very really easy way to start doing experiments of your environment, your infrastructure, to see where any single point of failure, any risks might be in the resiliency of the application. Okay, so it's also pricing is 10 cents US per action minute. So action minutes basically are, as you do an action, how long it runs for, and you get charged 10 cents a minute. So it's very inexpensive overall to do experiments. So let's take a look at FIS. Again, a very simple console right now. You can start out with experiment templates and experiments. Experiment templates are where you create your experiments, and the experiments themselves are results of experiments you have run. Hopefully you can see my screen. I didn't zoom in or out very far, but hopefully you can see everything here. And I've already run some experiments, kind of show you some things, but we'll also create some new ones here as well. Okay. So if I go into experiment templates, this is where you will define what you're going to do. And let's go ahead and take a look at this first one here. Again, I'm just playing with these things here. This is how I'm also discovering how the service works and make sure I understand it better. So it's very easy to experiment. You can deploy a very simple workload in a non-production account and learn how to use this as well. And so when you create a template, you will set up all these different things. I mentioned actions, targets, and then you're going to have other things along with that, right? So let's go ahead and create a new template to see how it's done. So the first thing you're going to give it a name. Let's call this second test. You also can tag if you want to with the key name. So I can say Community Ignite Series. And then you need to give it a role. Now, the IAM role is very important because you need to give it a role that has the ability to execute certain API calls. So what basically Fault Injection Simulator is doing is managing a process of making the correct API calls to the targets that you set up, and then have a ability to monitor for certain outcomes in certain states. Okay, so it's making it very easy. We used to write scripts and bash scripts and PowerShell scripts to call these things to the command line, these very API calls. Now it's very easy to do through the console, and it's also managed for us. I don't need to spin up any servers. I don't need to write any scripts. It's all done for me here. So we pick a role. I have a role I created already that is set aside for this. Okay, and we'll look in the role maybe a little later if we have some time. So once you create your description and name and give it the role to run, the permissions, you then have actions. And actions are what you're going to run on your targets, okay? And right now, targets can be EC2 instances, they can be RDS databases, they can be EKS and ECS. So it can also affect containers right now, okay? So we're going to do here first, we're going to say, this is a little wonky on how you do this, but you need to do action. So let's create an action here, and I'm going to say stop database. Okay, and you can give a description you want to as well. I'm going to say CIS for my tag. Then your action type. This is where you get the choice of what you can do. I can look for alarms and CloudWatch to be a certain condition to make sure the test can run or stop. Okay, I can reboot instances. I can also, if you're running Spot infrastructure, for example, you know how Spot will have potentially a notice that the instance will be reclaimed. You can simulate that as well. I can send an instance interruption notice so the instance pretends to go away, and then you see how your infrastructure handles the loss of an instance as a Spot instance. I can stop instances. I can terminate instances. Terminate obviously is a little more extreme version of stop. Terminate is usually means is the instance is gone. So whatever customizations you may have used in launch configuration or anything local in that instance is going to be gone. It's basically a deleted instance, whereas you can stop a stop instance, you can restart. Okay, and then you can do things like ECS drain containers instances. You can ECS stop tasks. You can EKS terminate node groups. You can see all the different things, as well as simulating some control plane behaviors. As Werner mentioned earlier, you can actually simulate, for example, an API internal error. You can simulate a throttling error, because for example, when you're calling services in AWS, you do have limits, and there are things that are API call limits and stuff, and throttling does happen at times. So you can actually simulate the effect of if something is being throttled. How does your application respond to that, right? How does your infrastructure handle not ability to do something, or it has to wait for it or such, or the API is not available? How does it respond to that? Also can do, for example, yes, questions? Okay. think no questions. Okay. Also, you can do wait conditions and such. And then here's the example: RDS, failover cluster or reboot an instance. Also, integration to SSM. So systems manager, you can actually send commands to an instance, or to do certain things. You want to send a command to do something. For example, maybe you want to kill a process, or you want to stop a running service. Also, you can start automations. So you can see all these things you can do, including some SSM types scripts that have been developed as part of this to do things like run a CPU stress simulation, or IO stress, or run a kill, like I mentioned, kill process, run a memory stress. You can actually stress your instance too and simulate things that are happening locally through this without having to write your own scripts. Okay, so this is actually it's actually really cool, because it's very tedious as part of infrastructure support and part of application development, engineering, design, is to account for these test cases, these scenarios, right? They're often not done normally, and then it comes down to who does it and how do you do it, and what's the process to update those tests when your infrastructure grows, application stacks change, those kind of things. So it's really kind of cool that a lot of stuff is being done now through a console. Now I wanted to do RDS. I'm going to reboot a DB instance, and I can start it after I can actually have actions I can run. You can chain things together, so I can start this after another action happens. And then I can pick my target. So I have to make a target here, and then I can do failover. So I can say force a failover if I want to, right? On here as well. You can do parameters that you can pass along with this. So then my targets. I have to add a target. First I got to save the action. Sorry, this was a little wonky. I got to save the action here. I now have my actions. My action is going to be stop database, which is going to be a reboot DB instance. I'm going to have a target. My target is already DB instance target 1, so I'm going to edit this target here, and I'm going to pick my database. I can look for through resource IDs. I can have tags and filters. I can do different kinds of things for my resource type. I'm going to look for my database here, and I'm going to pick that, and I can say all or just individual, like a certain number. Like I want to pick maybe 10 out of 20, or I'll do all of them, right? So in this case, I'll do all of them, and I'll save this. So now I have a experiment that is specific to this particular data resource ID here, which is this database instance. And then you can do stop conditions. What happens if alarm is triggered? I don't have the alarm set up here, so it's not going to populate for me. But if I had alarm set up, you can actually pick an alarm to say, if this alarm changes state, stop the experiment. And also, of course, you can tag things as well. You want to make sure you tag your experiments so you can actually trace through and everything. Okay, so I have this. I'll create this template, and we kind of have some extra checks in place, because you're actually potentially could be doing this in production. So I want to make sure you know what you're doing, right? You want to make sure you actually, this is a valid creation, a valid template you're creating here, and you understand what you're doing on here. So if I look at it again, you'll see my template is database instance target 1. My target is this database instance, and I can export things out as well. This is the JSON file for the template. This is how the template would look like. And then any tags and timelines, or when I want to run this. So just run over a course of a minute. Let me pull up RDS really quick here. Where is my RDS? There we go. And we'll look and see at my databases here. Just a second. Okay. Sorry, I should have had it already loaded up for you. Apologize for that. Okay, so I have one database instance right here. And this is my instance right here. It's running in US East 2B. It's a T2 micro. It's not very busy and everything. And it's also set for multi-AZ. So in this situation here, I could either simulate a failover, or I can just stop it or restart it. So I'm going to go back to my templates. Oops, where am I? Sorry. I need to go back into I want to open to a new tab. My mistake here. Okay, new tab. There we go. Okay. So where did I move that over to? Hey, I can't see because my Zoom little Zoom bar is right over my toolbar. Here we go. Okay, so I go back in here again, and if I was to execute this template, you see right here my new template I created, the database, which is going to be a reboot DB instance. If I run this, you'll see it should impact my instance. It should execute that API call to restart the database instance in RDS. So I can monitor my RDS console and watch it happen here, as well as watch CloudWatch and those kind of things here. Okay, so let's go ahead and put the monitoring on here so you can see what's happening with this, and we're going to run this experiment. And the way you run the experiment is very simple. You go into your template list, and you can name your templates. Obviously, you want to go ahead and start using good names and figure out a methodology for how you want to manage your experiments. But I will run this one here. I'll highlight this radio button here, and I will say start experiment. I'll start the experiment. I won't do any tag with this particular experiment here. And we want to make sure you know what you're doing again. So you actually have to say start to actually start this, because this could be disruptive. In this case, it will be disruptive. I'm testing an environment I set up for this, but now it's going to run the experiment. So it's been started. So now it's pending. It goes through a few states. It may have to check a few things and such, but the status is pending. It will wait a minute here. There's a timeline. I can refresh where it is on here and such. And we can watch RDS, and RDS will, you'll see it disrupt. Now, also in my website here, actually, I don't remember. Oh, there we go. So it's already gone down. So database is already bouncing. So let me refresh this here. It completed. So it already restarted RDS. You'll see here, already restarted. It was successful. If I go into RDS, we should start seeing disruption. Now this is for the last hour. Where is my state? It says available, but let's see what the refresh. So one of the challenges too is that when we're monitoring, things as well, sometimes it takes a while for the data we're collecting to be captured and be reflected back into our monitoring consoles, right? So one of the challenges I've always had when I was running large infrastructures was how frequently do you check the availability of something, right? Do you do it every 5 seconds, every 10 seconds, every 30 seconds? Because that, after you scale and scale, it gets to be a lot of checks running all the time. And so let's see what happens here. Do I have an event happening here? Instance restarted. Wait, is that right now? I think it is. Yes, it was right now, because this is UTC time. So yes, it just restarted right here. So you see in the log that the instance restarted. Our application went down. Our application cannot handle a loss to database. I did not do a failover. I could have done a failover, but in this case, I did not. So I'm simulating what happens that when we lose the database restarted, we're gonna have disruption in the website, which is, in this case, we want to understand that. So you will do a multi-AZ deployment, and you'll have a failover event, and you should fail over. It's still going to be disruption. So when a database fails over RDS, it's going to be short, but it has to fail over the connections and restart from the state that it has in the secondary at the time. So there is a little bit of disruption, but in this case, because I didn't do a failover, I just restarted, it's going to take a little longer for it to come up, right? So if I go back to here again, it says available. Let's see here. Let's go ahead and check everything. Let me go ahead and go back to this database again. It's up and now again. Let's see if it came back, if everything came back. No, it did not. So it should be back by now. Everything should be okay. Available, accessible. Create groups, everything is in. Let's check our logs. So this is what you use the experiment to run and see how things behave and figure out what's going on. So this is part of the experiment process, is to understand what happened. So why is my application still working? Nope, now it's back now. So you see, there was a disruption while database was down, but it came back automatically because it was obviously the web server waiting for that connection to be reestablished. So this is how you learn what happens in your environment. This is how you learn how to address things like Do I need to have a secondary database, or is there other ways I can engineer or design in my architectures to be more resilient? Can I use caching, for example, or things I could do that would let me, can I use static assets and maybe it would be so impactful? So let's try another experiment. So I already created a couple other ones here that I ran earlier, and I'll actually go back to experiments again. You'll see the status, the output. In this case, the experiment was successful or completed, so it's green. And let me go ahead and click into the experiment itself, and you can get certain things like what it was and timelines and those things. Basically, you got a very simple view of what you did. Okay. So you can actually have this, and this is also logged into CloudTrail. Okay. So you have a archive or a log of all the experiments you run, and you can actually stack experiments together and build complex experiments as well that we won't have time to get into today. This is a very introductory view of this. I have an experiment I ran earlier that failed, and the reason why it failed was that I used a different role, and the role did not have permissions. And if you look at the timeline here, whoops, can I pull this up a little higher? It never actually ran, and the action, so it didn't actually run right because it didn't have permission. So did we say here, not enough privileges to perform the required action? Okay, so this, if you have an incorrect role, you try to run your experiment, you might get an error back saying that the role you used did not have the ability to do the particular action that you chose. Okay, so let's go back into an experiment that was successful. And I'll show you it also. I'll run it again and show how it works. So I have another one here I created called, this one is stop all, I believe. Yeah, is this one or all? I forget here. This is all instances here. So this is where I took all the instances down at once. I created a section of all. I have a timeline of all instances. This is what I did here. I'm gonna run this again, so you can see what happens in my infrastructure. Actually, let me back up one further. I'm going to do a single instance first. So I have an instance here. Now, when I created this, I used an instance that doesn't exist anymore. So I'll need to update my experiment to have a new instance. So I can go in here and copy it to a new template, or I can go into my template into my template here, and I can go ahead and edit my template to update my things like my targets right here, right? So I can go in here and actions update, and I can go ahead and change things here. So my target will change. I have to edit my target. The one I picked here was FA65D. Let's see if that's here anymore. So does not exist anymore. So let's go ahead and refresh that. Yep, I have 4. I have a bunch more running now from auto scaling. Let's go ahead and update this. So change this, and we'll pick one of these instances. I'm just going to drop one. I don't care which one it is. It's just an experiment. Or I can do a couple of them. Let's just do like 3. Okay, I'll do a half of them that are running right now. So let's go ahead and save that and update the experiment template. You type update. And now I will run that experiment. So this is now our first test one again. I will go into first test and I will start. And we can see what happens to the instances when I run the experiment. So obviously, again, there's still a little wrap up time here. It's pending, and then it will start really quickly. Timeline is about a minute in this case here, right? So it's gonna, you don't do it instantaneously, but it does happen over time, and you actually can do other conditions as well and do weights and stuff as well. So it's gonna run, and when it's running, you'll see that my instances will start to terminate. So let's pull this down. Let's do this here. Okay, you see right here, stopping, and one is terminated already. So it's already stopping instances, but my website is still running because I have enough instances still actually serving content. The load balancer is handling that for me. If I go into my CloudWatch, you can see things like actually the delayed because of the interval. But you start to see here 500 errors showing up. There's errors showing up and stuff. You can actually alarm on these things, check on this, and tie it into the experiment as well, and do certain complex decisions in your experiment process. Okay, so oops, I can't see my menu bar again. Here we go. So back to here again, you'll see the experiment has been completed, and it was actually still running because it's going to wait for the instances to finish, and it's still stopping them, so it's going on. And let's see here. Let's go ahead and wait for that. Let's check on the status of the instances here. Some are terminating now. One more stopped. And let's see what's going on here. And let's see what the state is here. It's still running. Why is it still running? Maybe because I may have picked some instances that didn't exist at the anymore. Maybe auto scaling was replacing them at the time. So I would need to actually have a stop condition set up as well. Also monitor my Cloud Watch to make sure that I know what's happening in my environment. So, but you see here though, it did stop these instances, and the website still ran as expected. So I was able to confirm my hypothesis that my website is designed, at least on the front end, on the web server side, as a resilient infrastructure. Way I did my test with RDS, because I didn't do a failover event, my RDS went down. So that was actually a single point of failure in this particular situation, right? So as again, you can see how this tool can be used to collect different data and run your experiments. So it gives you a nice way to run different things and test out your application infrastructure to see where you need to focus on, right? So that's really what I want to kind of show you with this. Again, this was running a little up, it failed. So it failed probably because, okay. So this is a great failure here, because when I think what happened was the auto scaling was adding or replacing instances for whatever reason. And when it did that, I had selected one of those that was probably not available anymore when the experiment ran. So considered a failure because the target I picked wasn't there anymore. And when you get an experiment, you can actually see what happened and explain to you in this case, unable to start stop all targets. So that's kind of an important thing to keep in mind, is that you got to look at the feedback for what's happening with why things are failing and such. And here we go. Here's what's happened here. So we saw the state, it failed, and such. So again, let me go and try my other experiment then, because that one, maybe I picked the wrong instance, the wrong ones that were already being replaced. So let's go ahead and get a new refresh view of this. There are 3 running instances right now. Let's go ahead and just pick, okay, it's fine. It's 3 running. So hopefully we're only going to see the ones that are running when I update my template. Let's go ahead and update this. I will update, and I will change my targets to be these. Remove all these, and let's see what's here. Okay, now I only see 3. So that was kind of a strange case. We're just going to kill 2 of the 3. Whoops. Did I save that? Let me see here. Okay, it's saved. Okay, so now we'll just pick these 2 here, and the same thing, update the experiment and run it again. And it should take less than a minute to run, because it's going to, in this case, the timeline is only 1 minute. So let's go ahead and start the experiment. And now hopefully it will be successful, because I have picked valid instances this time. So on the back end, FIS is monitoring the instances, looking for the various states, and determining if it's been successful in completing the action that you described in your experiment. Okay, so, and also notice too, I didn't show you this, but you can actually have multiple actions set up, so our targets and stuff as well. I can go ahead and create a new template, and I can have multiple things in here. I can create action. This will be I'll just call this 1 for now. This is a reboot or alarm state. And I'll pick actually, let's do this. I don't have an alarm set up here. Stop instance. And I'll leave this alone and I'll save this. Whoops. Okay, A1. And then I can add another action. This could be, let's call this A2. Whoops. A2. And I may say, let's go ahead and say, I want to, let's do let's I don't have any ECS set up right now, so I can't test containers to show you that, but let's go ahead and leave this alone and I'll save this. And now you'll see that you can have multiple actions as part of your experiment. Okay, so let's go back into the experiments. The latest one should have been completed. Oh, still running. Let's see here, still running. So let's go back over this and let's see what's happening here in EC2. And it's not killing my instances for some reason. I wonder why. 5.7, 8D, 2B. Maybe my experiment is wrong. So let's try something else. Let's go ahead and do the one I already picked. Whoops, I always do that. I can just do the one that says down all servers. And I will just drop everything. So all instances, these 2 instances, I will delete this because that's one thing that you have to do right now especially with auto scaling. Now you can actually script these as well. This is done via, you can actually do this by, describe instance and write a script around this and call FIS via CLI as well, or an SDK. So you have the ability to do things like that as well, and automate a lot of these things and create your experiment templates and then dynamically add your targets when you need to. So this one would be all of the instances together. And the other one, it was just, I dropped 2 out of 3. So let's see what's happening here. Why didn't it call that? Let's see what happens here. I'm wondering if my instance are changing too quickly. Okay, this is all instances. Let's see how the other experiments are running. Oh, they failed again. So let's try this one, next one here. Let's try this one here, all instances. Let's start this experiment. And let's see what happens in this situation. I ran this earlier and it did work. So I didn't go through this. This is not the first time doing this, but I'm wondering now is because if my web servers are changing their state too much, or I don't have it I don't have it filtered and tagged the way I need to. I didn't tag my instances, which I should have done, made it easier. Okay, so let's see what happens here while we're doing this. And let's see, it's initiating. Oh, completed already. So let's see what happens here. Oh, that one worked. Okay, everything's dead. Everything stopped. So I go in my workshop now, you'll see that it's going to fail. 503 error because the website's down. Load balancer will give that because there's no valid targets available in the target group. So what's going to happen here, though, it's going to realize that, oh, all my targets are failed. I will start new ones. So you'll see that eventually this will recover automatically because auto scaling will address that. Hold on here. Let's see here. Are you starting anything yet? Let's go into load balancer or target group. Whoops. My scrolling is terrible today. I apologize for that. Target groups. Draining, unused, monitoring. 0 healthy right now. So it should be starting up new ones very, very soon. Remember, it's got to check health. You also got to pass health check. So when you're thinking about things too, when I set up, like, for example, load balancers and auto scaling, there are certain things it needs to determine if an instance is healthy or not. And you got to fail a certain number of times. In this case, we're going to have to fail 2 consecutive tests, which would be 15 seconds interval. So, and you wait for 2 seconds. So it'll be up to 34 seconds before it realizes that an instance is not healthy, which is why that the load balancer could be a little behind on getting new instances running loaded up here. So let's see here. 0 healthy, 1 unhealthy. Should be restarting these things for me automatically. It's still checking things here. Let's go on. So it will recover as it figures things out over time here. But so the experiment also could, in the experiment, I also can go back and say, I want to, if I encounter an error, like for example, I encounter a 503 error that I could see through CloudWatch, right? A 503 error, I could use that in my experiment to stop the experiment. And I also can have the experiment restart that target if I wanted to, for example, in this case. So you can do a lot more with it. I'm just waiting for my web server to come back. It shouldn't take that long, but it's taking a little bit more time to take. Of course, I'm doing a demo. That's what it always is. Oh, here we go. I got one available now. So one is coming up. And let's see now if I refresh. There we go. We're back. Okay. So you'll see a couple things here. Oh, almost out of time. Sorry. We'll wrap this up here in a minute or two, but I want to give you a good demo of how it works and how you can build experiments around this. We're going to do a lot more with FIS this year. I'm doing a workshop again. I'm doing a workshop later on this in Q1, Q2 that I'll be releasing. And so we will, you'll be able to see and play around and learn more about this amazing little tool to help you work through identifying potential issues and risks in your infrastructure using chaos engineering principles. Okay. There's a question. Should I go ahead and start questions now? Is that okay?
Yeah, sure. Go ahead.
Sure. Let me okay, let me go ahead and go back to my real quick here. Sorry. Okay. I have one more slide here to say for questions, so we know where we are. Okay. So question, does FIS incur costs? Yes, it does. It's 10 cents per action minute. So every action I ran there had a minute duration defined. So it would be every experiment in that case was 10 cents US to run. So it's not very expensive. You think about this, most of your experiments are going to be you're going to plan these things out. You don't just go in there and do cold and play around unless you're learning how to use a tool. But once you get the tool understood, you're going to think about your process. What are you trying to accomplish? Remember, as part of chaos engineering, you have to understand your normal state, and then you're going to have a hypothesis, what's going to happen based on unexpected behaviors. And so by knowing your normal state, you can then plan experiments that will let you inject fault scenarios that then you'll understand, see how your architecture behaves because of that. So your experiments won't be you won't be running them all the time. I mean, you're running them periodically, especially with new releases and those kind of things and such. Is really important early on, but at the same time, it won't be very expensive because if you can run 10, it's only $1 US. So it's not very, very expensive right now.
All right. Thank you so much for that. Thank you so much for that wonderful talk and demonstration, Sir Paul.
Sure.
And you know, it is indeed important to do experiments because this is where we discover and understand how the service works. So, all right, guys, I'm sure you still have a lot of questions for Sir Paul. So to our 126 Zoom participants right now and 31 live viewers in FB, ask away. So I have a question, Sir Paul. So what
Sure.
are some common issues we will encounter and how do we fix them? Like, or in case of automation flaws, how will we troubleshoot them? Like, what's your number one tip? Like, for example, just refresh it, like what you did earlier. So what tips can you give to us?
So a related piece of this process of chaos engineering is called observability. Observability means, do you know what's happening in your environment? How are you monitoring it? So really, you want to make sure you have an effective monitoring infrastructure to see when things aren't working. So I was manually monitoring my eyeballs by checking my website and seeing how instances are going. This is show you how it works. But if I set up the appropriate CloudWatch alarms or my other monitoring system I'm using to alert me, paging, whatever else, that is one way you can do that, right? So you're going to basically have your observations in place, and then you're going to see how they respond to that, which also you can use in experiment. But also too, maybe you don't know what you're not monitoring as well. Maybe you missed something. So this can also reveal that as well. So it's kind of a circular, like a flywheel, right? You're going to learn some things. You're going to add more monitoring. You're going to learn some more things. You're going to fix some infrastructure. You're going to learn some more things. It's the whole purpose of this, using chaos engineering. Okay.
All right, so let's have like last two questions. Another one is from Justin. On these actions per minute, those costs per minute will be fixed as 10 cents, or does it depend on a changeable properties?
It's defined right now as action minutes. So however long those actions take, that's 10 cents per action minute. So it's not much more clear to have that right now. Again, I'm still learning the service myself in terms of all those details, but that's the way I understand it. So whatever, if you have actions that are multiple actions running together and they take like 3 minutes to run, it'd be 30 cents to run for that experiment, right?
All right, so last question is from Michael. Does FIS works on virtual machine images imported from other sources?
That's a very interesting question. Not specifically, because what FIS is doing is executing API calls through AWS, right? It's basically control plane API calls. However, there is SSM integration using System Manager, and System Manager can manage fleets on premises or outside of AWS potentially. So there might be a way of using SSM hooks to simulate things in a virtualized environment. It's not part of AWS, but this is really, if you have everything running on EC2 or EKS or ECS or RDS, this is gonna be really easy to run experiments on directly and simulate those things. Okay.
All right, so if you have more questions, you may reach out to him on his social media platforms. So Sir Paul, will you let us know where to contact you? Do you have any upcoming events that you want us to know?
I don't have a slide prepared for that, but I'm on LinkedIn. You can find me on LinkedIn. A lot of you already have. So by all means, you can do that. And we do post things there. I'm sure I'll be hopefully invited back to speak again. So if I have anything else coming up, I do have a session, Singapore Summit in May. I don't know the details yet because it's still early on, but I'll be doing a session based on this for the Singapore Summit. So which is an ASEAN based summit for everybody around here. Okay.
Right. So thank you, Sir Paul. We hope to see you next time, and maybe you can do part 3 of this. We would love to learn more. And of course, thank you, Sir Paul. Along with the Community Ignite series, we also have more opportunities for free learning for you. So we have a lot of events that will suit your interests and fit the skills you want to learn. In fact, as cloud technologies continue to transform organizations rapidly, employees with the necessary cloud skills are also in demand. So we at Edukasyon.ph and AWS want to help you learn more and become a certified AWS cloud practitioner. So we offer a cloud training bootcamp through specialized courses, and the training is open to students and educators for free. So you may check this out on our Facebook post for more information, and you can register on or before February 2022 at go.edukasyon.ph AWS bootcamp. So let me give you the link right here in the chat box. And aside from the cloud training bootcamp, we also have Are You Ready for the AWS Restart program here in the Philippines. All right. So today, Edukasyon.ph is glad to be a part of the AWS Restart program in the Philippines. So what is AWS Restart? So AWS Restart is a 12-week or 3-month virtual training program that covers fundamental AWS cloud skills as well as practical career skills such as interviewing and resume writing. So it is to help individuals prepare for entry-level cloud roles. So this program helps prepare unemployed and underemployed individuals for new careers in technology through scenario-based exercises, labs, and courseware where students build Linux, Python networking, security, and relational database skills. So with this, we are inviting you guys to enjoy on this free AWS Restart program. You can apply on or before March 6, 2022 at go.edukasyon.ph AWS Restart. So let me chat it again here. Thank you, Atcha. And next up, di pa tapos, we also have a challenge for you brought to you by Accenture Philippines and AWS Club Pilipinas. We are inviting you to sign up for our Tech Explore Innovation Challenge. So here's our question for you guys. How might we use technologies like Amazon Web Services to help achieve any one of the following UN Sustainable Development Goals. So yun yung sasagutin yung question dyan. And we can't wait for what you have as an answer. So for more details about the challenge, please visit this link. I'm gonna put it there in the chat box again. All right, so yan yung Tech Explore, okay? Sala kayo dyan. And then, before I tell you guys all about the feedback form, I'm inviting you to more of our events this month. So our next Thursday, we're gonna have our CAS 29th episode. But before that, it's February 23, Introduction to CI/CD. And then, same day with our next episode is Getting Started with .NET with AWS. And then lastly, we're gonna finish this month with React.js Philippines. And also, don't forget to join AWS User Group Philippines meetup happening right after this episode. So it's definitely a must-attend kind of event, and we can't wait to see you all there. So treat it like a after party, ganun. So I'll see you guys there at the AWS User Group PH Monthly Meetup Part 2. Ayan. So punta kayo later ha. Ayan. So again, you can check all about this, all of our events, upcoming events, past events on our social media account. So make sure to follow our Facebook, Instagram, TikTok, and LinkedIn to stay updated. Search nyo lang AWS Club Pilipinas, or you can scan the QR code flashed on the screen. Is it here? Is it there? Is it here? Basta nandyan. Ayan. So, all right. Grabe, I have learned a lot from this 1-hour tech-driven webinar. Again, thank you so much, Sir Paul Sears. And we hope that you learned a lot in this episode. Now, before I talk about before I announce the evaluation form, I want to take this opportunity to invite you all in the photo op. So, open cam naman tayo dyan. So, start video. There you go. Let me see. Hello, Justin. Oh, hello, Archie. Is it Archie? I hope I didn't pronounce it wrong. Hello, John. Hello, Joshua. Hello, Sir Mark. Hello, Michael. Hello, Ralph. Hello, Ralph. Like kita nakikita sa Facebook. Ayan, hello. Hi, everyone. All right, let's take a picture. I'm gonna count to 5, 4, 3, 2, 1. Ako yung iba nakasmile na. Ready na mag-picture katulad ni John Floro. Hello, nakasmile na siya. Ayan, let's go. All right, guys, in 3, 1, 2, 3. All right, another one. Let's do like a wacky post naman, di ba? 1, 2, 3. Oh, naka-peace sign. Oh, ganun na lang ako. All right, yan. So, sana yung mga naka-off cam, naka-smile din, no? Para feel naman namin yung presence nyo, eh. Ganyan. And that wraps up the 28th episode of the Community Ignite series, AWS Fault Injector Simulator Demo. Of course, we would love to hear your feedback. And to answer our CSAT form, ayan na guys, yung evaluation form, please go to go.edukasyon.ph/CAS28 feedback. Again, that's go.edukasyon.ph/capital CAS28F and then feedback. So please make sure to provide a correct email address so we can send the e-certificates to you. All right. And speaking of e-certificates, don't forget to post them because by the end of the month, we will be choosing the top attendee of the month. So may ganyan na tayo, all right? And the winner will receive AWS credits worth $20. Wow! So compile nyo na guys yung mga e-certificates nyo and post it with the hashtag Edukasyon.ph and hashtag AWS Club Pilipinas. Again, that's hashtag Edukasyon.ph and hashtag AWS Club Pilipinas. Any day this month, okay? You can post it any day this month. And don't forget, of course, to tag us on the post. Again, thank you guys sa pagsubaybay sa amin. I'm so excited to see you all next week. And of course, see you on the AWS Meetup. All right? And then don't forget to join the C Club community because we have a lot in store for you. And that's all because of our co-presenters. Thank you to AWS and AWS C Club Pilipinas. All right. And once again, thank you, everyone. Stay safe, and I'll see you next week. Thank you. Thank you, Jaisal. Thank you, everyone. Ayan, yung mga naka-open ka pa. Thank you, Giselle. Thank you, Sir Archie. Ayan, kamasham, diba? Alright, thank you, everyone. See you on the meetup. Please join the meetup. Wait, that's all it.
You've earned an AWS certification. Congratulations. Now what? Show your employer, colleagues, and your customers that you've met the bar set by AWS experts. Add your digital badge to your professional profiles and email signature to highlight your skills. Share it on your social feeds to celebrate with your network, and offer verification via email or on your resume. Cloud skills are in demand, and you have them. Share your AWS certified achievement today.